right, hey guys. Today we're going to be going over a couple RNA in central dogma. The RNAs, there are three main ones and three regulatory ones. We're going to go over those just to kind of clear it up. We're also going to go over enzymes, a different category. We're also doing a live session today, so there's some people here who might ask questions, and we're just seeing how this works out. So let's go ahead and get started. Central dogma. If you guys don't understand anything, just go ahead and ask a question. It'll probably make it better for everyone else too. So in RNA, central dogma RNA, first let's go ahead and draw a nice DNA strand. Okay, so this is DNA, the double helix, and we have, let's say from here to here is a gene. Okay, now this gene can be transcribed, so you'd have RNA polymerase come in, and then it would go along and copy, and the copy would be an anti-parallel strand, and this copy would be made of RNA, whereas this down here is DNA. Okay, RNA, DNA. So this RNA, depending on the gene, you can have three different kinds of RNA. All right? So, and that also changes what type of polymerase you're going to have. There are three types of polymerase. All right. So we're going to go the three main ones here. We have RNA polymerase type 1, type 2, and type 3, which are going to make, if type 1 polymerase comes down and this happens to be an rRNA gene, then it will make rRNA. All right, the one that you guys are probably most familiar with, type 2 polymerase, will come and make mRNA. All right, and so that would be different gene. Now you have mRNA coming off. Okay, they're both RNA, they're just different types. They have different jobs, if you will. So the last one, tRNA. Okay, so tRNA coming off. Does that make sense so far? Okay, so if you have type 1 polymerase, it would be
rRNA.
Got it. And if it was type 3?
tRNA.
Good. Okay, so the polymerases change just because one polymerase happens to be good at doing rRNA. Okay, so, and they have different binding sites here, so that only the certain polymerase would bind and then initiate, elongate, and terminate, and have the RNA strand come off of the DNA. So, rRNA is really easy to remember because R stands for ribosomal. So it actually makes sense. Scientists named it right for once. Ribosomal RNA makes all of the ribosomal subunits except for one, because this is science, and except is a word we use. So I'm just going to put ribosomal. And we will go over the exact numbers, but really it's more important that you know the concept. Matter of fact, if you only know the exception, then you can just say all the other numbers are in that one, okay? Because the ribosome subunits do have numbers. So these are all the ribosome subunits. Okay, type 2, mRNA. This is the one that whenever you think of RNA, it is what you're thinking of. mRNA is the one that gives a transcript that gets cut up into introns and exons, and then it gets sent off to be made into protein. This is the one that actually is the one you hear about all the time. It's the popular one, okay? So we're going to put blueprint for protein. All right, tRNA. tRNA is the one that is used, if you remember, outside the nucleus. When messenger RNA has gone out there and it starts to be transcribed, you need amino acids to come down and link. And the tRNA is what those amino acids are bound to. So a charged tRNA is one that has an amino acid on it. It comes down, it binds to the E site, actually EPA, it's the A site in the ribosome. Regardless, the tRNA comes in and it puts that amino acid there next to the mRNA, so that the protein that the mRNA blueprint is for can be made. Okay, so tRNA is basically an amino acid carrier. Okay, so this gets amino acid carrier. So, and then I told you that there was one other thing that tRNA did. It also has the 5S subunit, which is used in ribosome construction. So the 5S subunit is in tRNA. All the other subunits are in rRNA. Make sense so far?
Mm-hmm.
Okay. Pause for just a sec. Close your eyes if you want to. And see if you can recall the 3 types of RNA and what their jobs in general are.
Type 1 is ribosomal, rRNA. It does the things with the ribosomes.
Good. All right. Type 2.
Is mRNA is the blueprint for the protein.
Good.
Protein. And type 3 is the amino acid with it's like a little buddy, and it goes and makes friends.
Yes, it goes and makes friends, and all the friends together make a protein. And then it has one special thing added onto it. What's the special thing, Derek?
5S.
That's right. Okay, so those are the 3 main RNAs, and they're just chains that come off. A polymerase will make all of them, whether
so
it's type 1, 2, or 3.
You need all types to get from transcription to translation.
Technically, yes, because if you were missing rRNA, you wouldn't have a ribosome. If you were missing mRNA, you wouldn't have a blueprint. If you were missing tRNA, nothing would bring the amino acids to the ribosome, and therefore you would have nothing to make protein out of. Good question. All right, so now that we've got these 3 done, there are 3 regulatory RNAs, okay? I'm going to go ahead and erase this little thing down here. These 3 regulatory ones are transcribed by a polymerase. You don't need to know which one for this. But some RNA that happens to float around and do special jobs are snRNA. And by the way, make sure that these are 2 separate ideas in your head. Don't be trying to make this into one long list in your head, okay? You've got those ones. Now we're going to regulatory. Put it under a different heading. It'll make it much easier to remember. snRNA, all right, and then miRNA, and then siRNA, okay? So, first off, I remember snRNA because it snips the completed transcript of mRNA, okay? So this thing comes in. You remember mRNA has introns and exons, and the introns get cut out. snRNA is the one that snips. I'm going to draw really bad scissors. Are you ready to see these bad scissors? Bam! Bad scissors, okay? Only cost you $1 at Walmart. So it snips out the introns from mRNA, okay? So that's what SN, snip, RNA. miRNA is one that they also named correctly. It's like a rare occurrence, so it's always so jubilant for me. All right, messenger inhibition. So this inhibits messenger RNA from being used. So inhibits mRNA translation. Okay, so what that means, yeah, go ahead. Okay, cool. What that means, just to wrap up really quick, we're running out of time, but mRNA, if you just let it stay there forever, the ribosomes would keep reading that mRNA blueprint over and over and over, and you'd have that protein made for like ever. So you don't want that to happen because that's a waste of resources, and maybe having a lot of that protein is actually bad for some reason. So you want to keep a balance. So miRNA inhibits the mRNA from being used too much. And eventually, you want that mRNA to go away altogether, not just be slowed down, and that's what siRNA is. It's the next thing, and it degrades. It signals the mRNA to be degraded. Degradation. Degradation. And that's an A. All right. So, for those of you at home, I would pause the video with this still up and see if you can go over the first 3 and then the second 3. Okay, the main 3, the regulatory 3. We're going to jet. So, talk to you next time.